dynamics, what we've got is we've got problems that are going to have some motion, where you're going to have an acceleration. So the connection between kinematics and force problems is the acceleration. So at some level, you're always trying to find the acceleration, and then you'll plug it into like an F equals ma equation. So we know that we've got 2 seconds of free fall, and they slow to a stop in 0.5 seconds. So the first thing I need to do is I need to find what speed are they at after 2 seconds of free fall. Okay, and so if you realize you're going to use the equation v2 equals v1 plus at. You know what a is. You're on the Earth. Starting with a v1 of 0, so this is equal to 0 plus 9.8 times 2. I mean, I can tell you that's 19.6 meters per second. So as they're falling, right, they get faster and faster and faster, and then they brake for a certain period of time. This is 2 seconds. And by the time you push the brakes, they're moving at 19.6 meters per second. So the question, though, is then they decelerate over some time, only a half a second. So now what we're going to do is we're going to use the same 2 equation, but now v2 is 0 equals v1. Now they're starting at 19.6 plus a times 0.5. And I got, what did I get? 19.2 meters per second squared. So now here's the question you've got to add. Figure this out. They are going down. I bet you've done one of these things. Does the person, when you decelerate, so you're moving down, and you either need to add or subtract 9.8 to this number, because you're trying to find the weight, which is the force. Force is mass times acceleration. Are you going to use 19.2? No. You do 19.2 plus or minus 19.8. So think about this. As you're going down and then they slow down, what direction does the acceleration go? Up or down? And then, so you'll add or subtract the numbers, and then you'll multiply by the mass, which they said was 65. By the way, to get the second part, boop, boop, boop. The second part, you're going to just take the answer to part A divided by their weight on the Earth. And their weight on the Earth is just 9.8 times 65, which I'll tell you, it's 637. So whatever you get from part A, not A for acceleration, when you get this force, let's say F, divided by 637, and that gives you a ratio.